All right, here we go. Who's got? Oh, I know. We gotta get our quizzes back. Because our test is the next time I see you, which is next Tuesday, right? So we'll start with this review right here. We'll start with this. Huh?
We bounced that.
Bounce
It's 4.
back.
I missed 0.01 points. How did that happen?
We're gonna find out.
0.01. 0.01.
Now remember, you actually missed more than that because we had a bonus.
We had a bonus.
That is wrong, take it. When that happens, people, you get rewarded because it hardly ever happens. Where's
Oh, okay, yeah. That's what
You're a little wet there, Brad.
I live really bad.
This is the highlight of the day. And now you got this. I have no idea. All right, so let's start. These are all going to be test questions, kids. They're all test questions. So let's start by taking care of any question that you have. All right? So, who's got a question? You missed something and you're not sure what. Ian?
No, on the quiz or on the homework?
On the quiz.
Okay, no, I don't know.
Okay, Jake?
Number 2, on number 2, I think.
Yeah, well, I didn't put hearts on these, so does yours say find a positive coternal angle for number 1?
No.
Okay, so which one is it, number 2?
Yeah, find
All right.
exact value.
All right, so find the exact value means, without a calculator, which you didn't have a calculator anyway, so that was kind of redundant, but we are finding the tangent of the angle whose cosine is 2/3. Since that number is positive, I'm going to draw that triangle in quadrant 1. And the cosine of the angle is 2/3. Cosine is adjacent over hypotenuse. Then I'll do the Pythagorean theorem correctly, people. Correctly. 2 squared plus b squared is 3 squared. So this is the square root of 5. And then I want the tangent of that angle, opposite over adjacent. So the answer is root 5 over 2. Okay? Paige.
Can you do 3 on that same version?
Same quiz, number 3. We are finding the period of this. So when we find the period of a sum or a difference like this, we find the period of each piece. So the period of this piece will be 2 pi divided by 2. Remember, period is 2 pi divided by whatever your coefficient is. In this case, it's 2. If I were going to graph this, I would want to factor that 2 out, but there's no need to do that for this problem because I'm just interested in period. All right, so that's pi. Here, my period is 2 pi divided by 3. So the first time they both start a new period together is the period. So This one starts at pi, 2 pi, 3 pi, 4 pi, da 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 da. This one is 2/3, 4/3, 6/3. I'm gonna stop right there because 6/3 is the same as 2 pi. So that's my period. All right, yep, Amanda. Same quiz, number which one?
3.
I just did. Well, then you're on a different quiz.
The number 2.
So, yeah,
So quiz 2.
well, they're both number 2, I did my own. So you wanna do number 3 on the other quiz.
Yeah.
So number 3 on the other quiz is writing your own equation, so it's kind of writing your own equation. And the picture looks like this. And it's labeled okay, like that. All right, there we go. So we're gonna write a sine equation and a cosine equation. Some of you goofballs wrote 2 sine equations. You need to write, yeah, congratulations. You need to write one of each, okay? You won't feel like one of each. So when we write a sine equation and a cosine equation, here are where all of the blanks, all of the extra new numbers can be. So notice that the amplitude of the curve is 1. So these are just ones or blank. You don't even have to put anything there for this problem. Okay, now let's look at it as a sine. Oh, by the way, it doesn't appear that there's any vertical shift. Let's look at it as a, well, what do you see when you look at that? What do you immediately see? You see a sine curve? Okay, that's all right. Starting here. Would that be one option for a sine curve?
Yeah.
You could start at other places, but sines start on the axis. Okay? So if you start there, then you don't have any phase shift because it's actually starting at the origin. But that number would have to be negative because it's going down first. All right, the only thing I need to do is find the period. So what is the period of this guy? 4 pi over 7. So I divided 2 pi by some number and it gave me 4 pi over 7. Well, what's that number?
You're gonna figure it out.
I am gonna figure it out. 7 halves? That number's 7 halves. 2 pi divided by this number gives you your period. I know my period is 4 pi divided by 7, so 2 pi divided by something gave me 4 pi over 7. So there's my sine equation. Now my cosine equation, it just depends where you want to start it. You could start here, that would be a cosine equation. And if you started there, this would be x plus pi over 7. Some of you started it here, which is absolutely fine. That would be, that's a 7. Aren't these 7s? Some of you started here, so that would be x minus pi over 7. And this would have to be negative out here because that's an upside down cosine curve if you started there. All right, Amanda? All right, anybody else from the quiz? Okay, so we're going to look at exactly the same problem on the other quiz. So I need, kids, you got to figure out where you're going wrong because we're doing exactly the same thing. This time we got 3s. looking at it, amplitude's 3. Phase shift, vertical shift is 0. Okay, so if I look at that as a sine curve first, I could start it there, right? So if I start it there, this is gonna be x plus pi over 4. It's a sine curve, it's starting on the axis. If you started here, it would be x minus pi over 4, and it would be positive. This one's gonna be negative, because I went down. What is the period of this curve? Well, I went from negative pi over 4 to 3 pi over 4. How far is that?
4 pi over 2.
How far is it? From negative 1/4 to positive 3/4. Yeah, 1 pi. So my period's pi, which means 2 pi divided by something gave me pi. That was kind of easy. That's a 2. Now, when I write it as a cosine, one option would be to start here and look at this cosine curve. It also is negative. And there is no phase shift because cosine starts on the axis. Now, if you started it over here, it would be a positive cosine curve, and the phase shift would be 2 pi over 4 or pi over 2. Got it? Figure out what you did wrong?
Yeah, I just said the wrong page. It started on this.
Okay, that's science, start on the axis. Okay, anything else from the quizzes? Ian,
Number 6 on the other one.
where it says find the period?
Yeah.
Okay, now we've done one of these too, so figure this out. They're all exactly the same. So figure out what you're doing with your numbers, that it's not working out. Because, all right, so we've got 5 sine 5x minus 3 sine 3x minus pi. So what's the period of this one?
2 pi.
2 pi divided by 5, which means 2/5, 4/5, 6/5, 8/5, 10/5, 12/5, and so on. That's how it repeats. Every 2/5 pi, it repeats. All right, what about this one?
2 pi over 3.
2 pi over 3. So this one is 2/3, 4/3, 6/3, wait a minute.
That's it.
6/3 is the same as 10/5. So your period is 2 pi,
Okay.
right?
Right. Right.
You figured out what you did wrong?
Yeah.
Okay,
What's the period?
2 pi. It's the first time they match. 6/3 is 2, 10/5 is 2. It's the first time they
Okay.
match.
I get it.
Right, anything else from these? All right, put those away then, and let's look at what you came up with in terms of review. Last chance, you were supposed to find some questions in
Number 4 on 4.8.
homework.
Yeah.
Homework 4.8. Okay, so I'm gonna say it again. We did this problem yesterday, and it's okay, I'll do it again, but they're the same.
Like the same numbers and everything?
No, the numbers are different, but you got a calculator.
Okay.
Alright, so what's happening is, we're standing at the top of this 150-foot building, And actually, this one's gonna be a little easier than the other ones. There's a car, this girl's looking at this car out here, and the angle of depression is 18, but then the car is moving toward her, so her angle increases and it's now 42. So here she is, she looks down, sees the car's coming toward her, so she looks down and looks at it again, and that's all I know. The question is, how far does the car travel? So this right here is my X. That's what I'm looking for. Okay? Now, let's look at the big triangle. The whole big triangle. Let's call this A. Looking at the whole big triangle, can I find A? Tangent 18 equals 150 over A. That's a right triangle, so good Toa. Tangent 150, or tangent 18 equals 150 over A. So A tangent is 150. So I'm not going to type this in just yet, but that is going to give me A. Ian, would you agree with that? Now I'm going to turn around and I'm going to do exactly the same thing with the smaller triangle, and I'm going to find this, which I'll call B. So tan 42 equals 150 over B. So B equals 150 over tan 42.
Yeah.
So I plugged A into my calculator, I get a number. I get a number for B, and then I will simply do what with my A and my B?
Adam.
Add them.
Yes.
I'm looking for X.
Oh, with your A and your B. Subtracting. Yeah, my bad.
So you're gonna take A minus B, and that's gonna give you
Right.
that little piece, yeah. Jake?
It's the Precal A review sheet 4,
Okay.
and it's the second 5, so like on the right side.
Uh-huh. Yep. So it's number 26, 5.
Yeah.
So we're finding the area of the shaded region. Radius is 6, that's 95, but the shaded region is this. So you can do this a couple different ways. The most efficient way of doing it is to say, okay, if the little angle, so this is like a pie, somebody's cut this out, this is mom's piece of pie, and then you're eating this piece, all right? Well, mom's angle is 95. What's your angle? What's this angle right here gonna be?
360 minus 3.
Which is what? 265? So you want 265 3/60ths, that's your fraction of the pie. And the whole area is 36 pi. So we're just gonna take 265 over 360 and multiply it by the whole area. That's your fraction of the pie. And in this case, the 36 will cancel and make this a 10. So really it's not gonna be as bad. You're gonna have 265 over 10 pi, and then you can divide by 5 and get a simplified fraction. Kara?
So just to get like that slice, you would just do 95 over 260?
Yep. And you could still do that. If you did 95 over 360 and found that area, then subtract it from the whole area, that would give you this piece. So if that makes more sense to you, that will absolutely work also. All right, who else? Yeah. Ed,
Can we do number 2 on 4.8?
4.8 homework?
Yeah.
Number 2. We are angle of elevation at the top of the building, have a point 100 meters meters away from the building is 78 degrees. Find the height of the building. Got it?
Yeah.
So tan 78 equals x over 100, and x equals whatever 100 tan 78 is. All right, what else? View sheet 4, number 25, we did that one already. Our revolution or rotation is 360, so it's just 2/3 of 360 negative.
Review sheet for 12B, the second one.
Already did it. I
Already did that?
The first review day, I did that. Somebody
Okay.
wanted another example, and I did that very problem looking at it. They,
Homework 4.5. What A?
4.5 homework, A. Alright, so let's just refresh our memories here for a second. What does a tangent look like? Just a standard regular tangent. Asymptote at pi over 2 and negative pi over 2. And squiggly line up through the origin, right? Okay. The 3, for our purposes, will have no impact. The 3 actually straightens out your curve, so instead of being, real curvy, it's more straight. But the way we're sketching, we're not even worried about that. The only time we would be worried about that 3, you and I, in this class, is if it's negative. Then we have to worry about it because it's upside down. So I'm going to forget the 3. What does that number always do? That number right there divides the period. Now, if it's a sine or a cosine, the period's 2 pi. But not a tangent. What's the period of a tangent? Pi. So the period of this guy is going to be pi over 2, which means asymptote to asymptote is pi over 2. Okay? Furthermore, what does that do? That takes it pi over 6 to the right. So now, the origin, which is this dot right here, that origin is now at pi over 6. There's an asymptote over here, there's an asymptote over here, and it squiggles up through the origin. Now, where are the asymptotes? I don't know, but I know they are half a pi apart. If they're half a pi apart, then what's this distance right here? Pi over 4. So I'm going to take pi over 6 and add pi over 4. And that's how I'm going to get that asymptote. How am I going to get this one? Pi over 6 minus pi over 4 is going to give me that one. So I'm going to get a common denominator. Between 6 and 4, that would be 12. So this is 2 12s plus 3 12s. So this asymptote is at 5 12ths. And then backing up, same thing, it's going to be 2 minus 3, so this is going to be negative pi over 12. Now, you won't have to graph, I promise, anything any more complicated than that one. You won't have to graph any secants or cosecants, and nothing more complicated than that. When I say you may have to graph a plane cosecant or a plane secant. So remember how we did that? We drew the sign and look back at your notes.
Can we do another one like that then?
Another one like what?
Like the cosecant, secant.
Find one.
Basic.
Find one. I'm not doing, the regular secant and cosecant are in your notes. Just look at them and memorize them. And you're not gonna have to graph anything else, so I'd rather not. Because the only ones you're gonna have to graph are the standard ones, if anything. And they're already in your notes. All right, so what else? Van, was your hand up? No, oh, I forgot, you got it, that's right. You got this, promise me, okay.
5 on the Christmas gift worksheet.
Christmas, number 5. Cosine 11 pi over 6. What's exact means no calculator. So what's probably the first thing you're gonna do with the cosine of 11 pi over 6? Change it to degrees. So put 180 in there, and that's gonna be the cosine of 330. Okay? Well, where's 330? I gotta draw a picture of it. Where's 330?
Bottom right.
Isn't 330 down here?
Yeah.
The important angle is this one, which that's 330, so that guy right there is 30, which means 1 root 3, 2, and that 1 is negative because of where we are. Cosine. Cosine is adjacent over hypotenuse, so the answer is root 3 over 2. Tangent 2 pi. Well, I think I'll do the same thing. What's 2 pi?
180.
No, 2 pi is not 180. 2 pi is 360. So I'm finding the tangent, oh wait, that's not, oh yeah, that's 2 pi. 2 pi. So that's tangent 360. Now, what's special about 360?
The circle.
Yeah, when I draw it, it doesn't do this, it's right on the line, it's right here. This is 360. So I'll draw my circle with a radius of 1. So I know this point on my circle, that's the 360, the 0, 360. What is this point? 1 comma 0. So x is 1, y is 0. And I am finding tangent,
2 over it.
which is y over x. So y over x is 0 over 1, which is 0. 0 over 1 is 0. What's undefined? Can't, Hollis, she says it all the time, you can't sit on the A, you can't sit on the A. 1 over 0 is undefined. All right, and finally sine 135. 135 is over here, would you agree with that?
Yeah.
And if this is 135, then that guy is 45, and we have 1 root 2. Negative on that one?
Yeah.
We want sine, opposite over hypotenuse, root 2 over 2 would be the answer to that one. All right, Karen?
On the back of that, number
13, so the Christmas thing, 13. State the sign of 100. So we're not typing, certainly we can type that in our calculator, we're not gonna have a calculator for this question. You're going to have to know how do you find the sign of 100. Well, where's 100?
A little bit past 90.
So it's in quadrant 2. So we have a triangle in quadrant 2, right? And what do we know about the sides of the triangle in quadrant 2? We know this one's positive, that one's negative, and the hypotenuse is always positive. So what sign? Opposite over hypotenuse. So positive over positive is positive. Tangent, negative pi over 7. Well, you can change this to degrees if you want, but it might, I hope you're at least thinking about the fact that this would be negative pi over 2, because this is negative pi, negative 180. Is pi over 7 bigger than pi over 2 or less than pi over 2? Less. So isn't negative pi over 7 down here?
Oh, you said it. It's not.
Less.
right? Now, you can change it to degrees if you want. You don't have a calculator though, so you're gonna have to do some division, 180 divided by 7. But pi over 7 is less than 90. So it's gonna be here, this is positive, negative, positive. Tangent is opposite over adjacent, so the tangent will be negative. And 1,000, now wait, 1,000 is just 2a. So what do I do when my angle is more than a revolution? Subtract a revolution, right? Or as many as I need to. So if I subtract 1 360, it's still gonna be 2. So I'm gonna subtract 2 360s. 280, are we gonna get 280? So 1,000 is graphed in the same place as 280. So where's 280 graphed? Just past 270 in quadrant 4. So positive, negative, positive. I want cosine. Cosine is adjacent over hypotenuse, positive. Right? Another way to think about those problems is cosine is always x, sine is always y. So if you are in quadrant 4, x is positive, cosine is positive then. Y is negative, sine is negative. Cosine's x, sine is y. All right, what else? Drew? Review sheet 4, number 8. All right, this was on. Well, what are the other 5 trig functions, Drew? What are the other 5 functions? Cosine. Cosine. What else? Tangent. You need all 5 of them, so keep going. Uh-oh. Secant, cosecant, and cotangent?
Yeah.
Now, if I know the sine is negative 3/4, then I automatically know my cosecant is negative 4/3 because sine and cosecant are reciprocals. To find the rest of them, I'm probably going to need a picture. This tells me where to draw my picture. Where am I drawing my picture? Quadrant 3. Kids, here's 180 and here's 270. I'm in quadrant 3, I'm between them. The sine is negative 3/4. So what do I need to figure out? The other side. I will use the Pythagorean theorem.
It's like,
X squared plus 3 squared is 4 squared.
pretty sure it's root 5.
It's not.
It's root 7.
Is
My
x
bad.
squared plus 9 is 16, so x equals the square root of 7. Only in quadrant 3, it is going to be negative. We have to pay attention to our location. All right, now I can fill in everything. Here's my angle, this is adjacent, opposite, hypotenuse. So cosine is negative root 7 over 4. Tangent is actually going to be positive 3 over root 7. I'll rationalize it in a minute. Secant is the reciprocal of the cosine. And cotangent is the reciprocal of the tangent. So this one's 3 root 7 over 7. And this one's negative 4 root 7 over 7. Okay, Drew? Easy problem, lots to remember. All right, let's do another one more, let's go.
Can we do homework
4.6 homework, number 1. Here's the negative sign right here.
It is like, when we put it in our calculator, I think that error, so I changed this.
Okay, we're on in radians. My window is negative 2 pi to 2 pi. And type in my equation, negative. Now, when you, yeah, I'm not sure how you typed it in, but you're going to type this. That's how you have to put it, you're squaring the tangent. So negative tan x squared. And it throws in those extra parentheses too. This time the calculator automatically puts in the first one, so they close it, but that's what it should look like when you put it in. And then when you graph it should look like that. Yeah. All right, time for one more. That one didn't take very long. Time for one more. Who's got it? All right, we have a test on Tuesday. That's the next time I see you. Seems like forever from now. But we have our test.